Intro to probability. So probability is the likelihood or unlikelihood of an event happening. So we rate it on a scale, or we think about it on a scale of between 0, so something is impossible or very unlikely, all the way up to 1, so it is certain or very likely. And then obviously everything in between, so your midway would be that half. And this is why probability is talked about in decimals. So it's half, which is 0.5. It's talked about in fractions, but it's also talked about in percents. And for grade 4, we're just going to go with the scenario that makes the most sense, but eventually you have to write it in all three forms: fractions, decimals, and percents. So if event is certain, it would be 100%, or here 0%. So what about the likelihood that it is going to rain, or let's go with it's going to snow in July where we live? Well, that is most definitely unlikely, if not impossible, for where we live in July. Now, trying to get it here, that it will rain in July. And what is the likelihood or the probability that that's going to happen? Now, you could probably put it anywhere from the 50%. This is one that would need your explanation and your reasoning. And maybe you would go look at the data from last July and how often did it rain. So I'm going to leave it right that it's a 50-50 chance, because sometimes it's very dry and it's actually more unlikely. And then sometimes we have a very wet July, and I haven't looked at the data. So I'm going to leave it at 50-50 at this point for my reasoning. So what if we have something that's less arbitrary and more concrete, like flipping of a coin? So when you flip a coin, you have two outcomes. You have a heads or a tails. So that's why we write a denominator of 2. There's 2 possible scenarios that could happen. And if I want to know what's the likelihood or what's the probability of flipping a tail, there's only one option that could be, and it's a tail. Heads, there's only one scenario. When I flip a coin, it could be a head. So that is why there is a 50-50 chance that when you flip one coin, you have a 50% chance of landing on heads or landing on tails. So does that mean that every time you flip a coin that it's going to be guaranteed to be split down the middle 50-50? So if you flipped it 10 times, are you going to get 5 tails and 5 heads? Well, no. And that's why we have theoretical. So this is the theory, this is the calculation, that there should be a 50% outcome. But then we have experimental, and what really happens when we do this. So if we take the data that you guys made, and we can see that this is after 10 flips, it's not exactly 50-50. Here's 7 out of 10 for heads and 3 out of 10. Now this person did get 50-50 their first time, but then when they kept going and they did 20, it was no longer 50-50. So you can see the different data. But what happens is the more often that we do an experiment, the more likely it matches its calculations. So if we take the sum of this whole row, or this whole column, it should be closer to 50%. And if we divide it by, there was 15 submissions and 30 flips. So this is saying that there's 15 trials here going down, and each of these were done 30 times. So 15 times 30. And that is 0.50, so 50%. Whereas if we did it here, let's see, if we take the sum of the row, so I'm in the column, and we divide it by the amount of trials, and there were 15, and this time there were 10 flips in this first row, still 50%. So usually this first column isn't as, usually you can get this one to be 70. Let's just do this one since we're here. Sum, and it's different every time. Sum of the column divided by how many trials we had, and we did 20 flips, and we had 15 people, 54, so this was higher. So it didn't stay 50. I'm quite surprised that this one is actually at 50. Usually I get this one to be at 70 or 40, and then as you get closer you can see it's 50. And if we did the other side, it would be its counterpart, because remember the total would have to be 100. So this would be another 0.5, this would be 0.46 and some. Now what about a spinner, or picking something out of a bag? So if you had 4 marbles or M&Ms in a bag and each one a different color, and you picked one out, what are the chances or the probability of it being one of these colors? So we think about how many outcomes are there. Well, there's 4 different equal outcomes. And what's the chance of spinning yellow? Well, there's only one yellow section. So 1/4 or 1/4 we know is a 25% chance of getting yellow. And now all these sections are equal. Now let's pretend that these two are the same blue. There's 4 total outcomes, but there are 2 blues. So you would have a 50% chance of landing on blue. Let's saying that these two are the same blues. So let's take a look at that. Now they're calling it cayenne. Cayenne? I'd call it teal. Can I change that? Look at that, teal. And they're saying everything is an equal 25% chance. It's 1/4. And if I spin it, the first time was blue. Oh, twice now. 3 times. There we got some red. So now you can see this data changing every time. And the more times we do it, the more likely everything's going to end up at 25%. Okay. You can change the amount, and then you could even make them not all equal events. So this was in that Desmos activity of making a section really unlikely. So it is very unlikely that red could be landed on 5%. Now it's not impossible, we can't make it 0, it still has to have some possibility, but I would say anything above that 10 would make it more likely. So you want to keep that small, and now it's very unlikely that red would happen. And when I started spinning it, it was landing on this blue the most often, but as I do more, and I'm going to do 10 spins, more and more experiments, it's becoming to match their probability, the theoretical probability. So in grade 4, we don't worry about calculating every segment. We do want to know that we do want to be able to calculate the ones that we do know. We know quarters, we know halves, we know 3/4. I think some of you could even realize that if this was a quarter and you went in the middle, we know half of a quarter is an eighth. So if a quarter is 25, what's half of 25? You would know that this is 12.5. So you could use your logic and make complicated spinners. It'll be up to each of you. But for grade 4, we're going to worry about what is from the scale of impossible, unlikely, all the way up to most certain, likely, and being able to calculate some simple theoretical probabilities of their outcomes, and being able to do some experiments.